In question 12, they give you the IUPAC name for a molecule, and they want you to draw the molecule. So in this example, we don't have any branches, and you know because there's no YL. Or if you had a halogen, anything in group 7A, fluorine, chlorine, bromine, iodine, you don't have those with an O at the end. So for example, fluoro, chloro, bromo, iodo. Any of those would be a branch, and anything ending in a YL would be a branch. But we don't have that here. So we just want to draw the molecule. And just the backbone, the chain, the one chain that there is. Now the prefix is pent, and that means that we're dealing with 5 carbons. So you could say, okay, 1, 2, 3, 4, 5. The infix that they give us is En, and what that means is that we have at least one double bond. Okay, but where should I draw the double bond? And to do that, I'm drawing a molecule. I can number this over a 1. I'm going to number it left to right. So like this. The number that they give me is a 1. And so the double bond is going to start at carbon 1, and it goes to the next carbon. So we have a double bond there. And the rest are going to be single bonds. And then, last but not least, the suffix is an E. And so there's only going to be hydrogen and carbon in this molecule. At the other end of all of these bonds is going to be a hydrogen. And this is the Lewis dot structure. You could also draw this as a skeletal structure. And to do that, you would draw 1 dot for the first carbon, and then you do a zigzag. So that's 1, 2, 3, 4, 5. All of the hydrogens are implied. We just have to put that one double bond between carbon number 1 and carbon number 2. So just to make that really clear, notice how in this example, the double bond is between carbon 1 and 2, and in this example, it's also between 1 and 2. So either of these would be correct ways of drawing 1-pentene. Alright, here we do have a branch. We can tell by the YL, and everything after that is the parent chain. So this whole thing after the last YL is the parent chain. So the prefix we have in this parent is but, which means we're dealing with 4 carbons. 1, 2, 3, 4. And I'm going to number them. I could number them however I want because I'm drawing a molecule. I'm going to do it left to right. The infix is En. That means that I have at least one double bond. Where do I put the double bond? It starts at carbon 1, the number immediately in front of the backbone. So it starts at carbon 1 and goes to the next carbon, carbon 2. All of the other bonds are going to be single bonds. The suffix is E, and that means that we're dealing here with a hydrocarbon. So after I'm done putting all the branches on, I'll fill in all the bonds with a hydrogen. So that's our backbone. Now let's move on to our branch. We have a branch coming off of carbon 2. And this branch has prefix meth. That means that there's going to be 1 carbon in the branch. So 1 carbon branch coming off of carbon 2. The YL just means that it is a branch. And so we fill in all of these with hydrogens. And this is the condensed, well, this is the Lewis structure for this molecule. Now, if you wanted to draw the skeletal structure, draw a dot for your first carbon, and then do a zigzag. Now I'm going to go 1, 2, 3, 4. So that would follow that backbone. Now notice, in between carbon 1 and 2, we have that double bond. And then on carbon 2, we have the methyl group coming off. So both of these are correct ways to draw 2-methyl, 1-butene. How about 3-methyl cyclohexene? Now we start by drawing the backbone. And you know where the backbone is because it comes after the last YL. YL always indicates that it's a branch. So here our backbone is cyclohexene. The cyclo means that whatever we have, it's going to be in a ring. Hex is telling us that, oops, hex right there, is telling us that we're going to have 6 carbons. Now a 6-carbon ring looks kind of like a hexagon, so you can put carbons at each vertex, each point of that hexagon. The infix, the En there, is indicating that you have at least one double bond. Now if you notice, there's no number here, and so it doesn't matter where you put that double bond. The reason why there's no number is because no matter where you put it, you'll end up with the same backbone. The E here just means we have a hydrocarbon, so after we're done filling in all the rings, we'll fill in all the bonds with hydrogens. Now, all the other bonds are going to be single bonds, and so we've got those. So that's our backbone so far. Now, how about the branch? We have a branch coming off of carbon number 3. Now we know we have to number with number 1 being one of the carbons in the double bond, and 2 being the other carbon. You always follow from one end of the double bond to the other. But aside from that, whether we went clockwise or counterclockwise wouldn't have mattered. Now in carbon number 3, this one right here, we're going to have a methyl branch coming off. Meth is a prefix indicating that we're going to have 1 carbon in this branch. And YL is just telling you that it is in fact a branch. So we've done that branch, and now we just make sure that everything has a single bond. And at the end of after we've done the branches, at the end of each of these bonds, it just goes in H, because this is a hydrocarbon. The parent chain ends in E. So this is one way of drawing 3-methylcyclohexene. Another way you can draw it is to draw that hexagon. Each vertex represents the carbon. The hydrogens are implied. We have that double bond there. I'm going to number it just so you can follow along and compare the two structures. And on carbon 3, we have that methyl branch coming off. And so these are both legitimate ways to draw 3-methylcyclohexene. But 1-chloro-3-hexine. Now here, your last branch is the 1-chloro. Remember, chlorine is one of the halogens in group 7A, and when those are branches, they end in that O. So 3-hexine is our backbone. And this backbone prefix is hex, and so it's going to contain 6 carbons. The infix, YN, indicates that we have at least 1 triple bond, and that triple bond is starting on carbon 3. So I can number this however I want. I'm just going to number it left to right. So starting on carbon 3, going to carbon 4 is the triple bond. The rest of the bonds are single bonds. And make sure all the carbons have a total of 4 bonds. The suffix E mentions that you have a hydrocarbon. So only hydrogen and carbon. Once we're done filling in all the branches, we'll write an H at the end of every bond. Now, there is one, so that's the backbone so far, and they do have a branch. The branch is 1-chloro. So it's going to be coming off of carbon number 1, and chloro is just telling you that it's a chlorine that's coming off. And then you could have written it on the side, you could have written it on the top. Either way is the same, because this bond rotates, and so all those positions switch places in the 3-dimensional molecule. Because it's a hydrocarbon, at the end of every other branch goes a hydrogen. So this is the Lewis structure for 1-chloro-3-hexine. We can also draw this as a skeletal structure. And I find that when you're drawing an alkyne, a molecule that has a triple bond, in a skeletal structure, start with the triple bond. You'll see what I mean. So start drawing that triple bond, and I would even number it. So for example, 3 and 4. Now triple bonds are linear, so you don't have a zigzag coming off of the triple bond. You have a line and another line. Here on the right, that's carbon 5, and here on the left, that's carbon 2. So now you've dealt with the triple bond, you can start going back to the zigzags. It doesn't matter whether carbon 6 goes down or if it went up, but it will be a zigzag. It doesn't go straight. Coming off of carbon number 1, again, it doesn't matter whether it goes down or up. It will be a zigzag though. And so those are your carbons. we just have to put in the chlorine coming off of carbon number 1, and that is 1-chloro, 3-hexyne. So both of these are legitimate ways of drawing 1-chloro, 3-hexyne.